Welcome back, my dear students. As we are studying the basic concepts of the thermodynamics here, so we are studying some important terms for that thermodynamics here. Now we will study thermodynamic system, that is a TD system. TD system means what? Thermodynamic system is nothing but it is the matter. It is the matter. This is the matter or any interested matter on which or through which we are studying the energy interactions. So how this one? What is this one? This is the definition here. This is the matter in which we are interested to study that the energy interactions here. So what is this one? For example, if I take a piston cylinder arrangement here, this is a cylinder and this is a piston which is freely moving here. So this is a cylinder here, this is a piston here. It is a freely moving, up and down it is a freely moving. Once that fuel will be burnt here plus air O2 burnt here. So now the piston is at this position 1 here. So what I will do here, I will take this is the dotted line. This is called as the system. What we want to study here now? So this is there here now. This is a system. So we are interested to study that energy interactions in this system. System means it is a matter here, that is a fuel plus air. Fuel plus air is the matter. So after burning, what happens inside? So after that what happens? By that what happens? On which what happens? So that interactions of the energies for this matter we want to study here now. So what I will do here now, for this matter I will make a dotted line here now. That dotted line is called as the boundary. That boundary is called as the thermodynamic boundary here now. It covers that system or matter on which we are interested to study. So what I will do, what is this now? This is thermodynamic system means what we have studied, and that thermodynamic boundary we have studied here. So outside this boundary what it is there here now? So outside this boundary, this is called as the surrounding here. This is called as the surrounding here now. So in arbitrary way, if I write, this is the system here now. This is system, this is a boundary here, and outside of this one is, it is called as the surrounding here. So next what happens here now? Next what happens here in this case? Energy interactions we are studying here now. So once that fuel plus air is air are mixing and burning, heat energy will be developed. Once the heat energy will be developed, what happens here? So it will apply certain pressure force on this piston here. So means what? Heat is going out of the system. Heat is going out of the system here now. If the heat is going out of the system means what? Heat is converted into another one form of energy, that is work here. So therefore heat is going out of the system means it is a sign conventions for the system is taken as heat going out of the system is taken as heat is going out of the system is taken as a negative here. It is a sign convention wherever. Heat will be represented as always Q here. Heat will be represented Q here. So next what happens? So this heat energy is there. This heat energy is converted into work here now. So work is done by the system. So therefore if the work is going out of the system, then sign convention it will be taken as a work done by the system is taken as a positive here now. The work is represented by W here. In the similar way, if the heat is added to the system here, if the heat is added to the system or heat is generated in the system, then that Q is taken as the positive here now. Then next one is work done on the system here now. Work done on the system, it is W, it is taken as a negative here now. These are the sign convention in case of the system here now. Especially in case of the IC engines, such IC engines here, work is produced here. So therefore heat energy is converted into work here now. So therefore here positive work we are getting here now. Here in this case such systems positive work we are getting here now. So next one, if we took a pumps here now, in our house we have pumps, we have refrigerators, such systems we have to supply the work here now. Means what? For the pump we have to supply the electrical energy through the motor. Means we are supplying certain amount of that work to that pump. In case of the refrigerator, we are supplying the electrical current through to that compressor. So therefore work we have to supply to them. So therefore this refrigerator, pumps, blowers, such systems are there. Here we are supplying the work from the outside. So work done on the system. So therefore here that work is negative here. So therefore this is the work done on the system, work done by the system. Heat will be added to the system, heat will be removed from the system. Heat is removed from the system is negative, heat is added to the system is positive, and work done by the system is positive. Work done on the system is, that is work done on the system is a negative. So therefore these work and heat interactions on the system we are going to study here now. How we can say here now, we are also studying in the thermodynamics the interactions between the surrounding and the system. Interactions, that is work interaction, heat interaction, like any interactions. So that heat and work interactions we are studying here now, that is also called as the thermodynamics. Mainly this thermodynamics, this system is classified into three types here. So this system is classified into three types here in this case here. First one, that is called as a closed system here. Second one is open system here, and third one is isolated system. Isolated system. First one, the closed system means what? For the closed system, example is this one, IC engine. What happens here now? See here, fuel and air is burning. After burning, heat energy is converted into work here now. So what is happening? Heat is transferring. Yes, heat is transferring. Heat means energy is transferring. But whereas mass will not come across the boundary. Now, when that energy conversion is taking place, at that time, it is a totally closed one. See here, this is a closed one. Mass will not across. In case of the closed system, if this is a system here now, the mass is barred here now. Mass is barred. Mass will not come from inside to the outside system, outside to the inside. Only the energy will crosses the boundary. Maybe from outside to inside, or inside to outside. That kind of system is called as the closed system. And open system. So open system here. Open system. What is the open system here? You know, in case of the centrifugal pumps which we are using in our house to lift the water, what we are doing? We are energizing the water by supplying the work from the outside. Then energized water will be lifted to a certain height. It will be stored at a height. Means what? Total mass of the water it is there. Once it will take the energy, it will crosses the boundary and going out. Means what here now? Energy as well as mass will crosses the boundary. Maybe from outside to inside, inside to the outside here now. So mass and energy will be there here now. both are crosses the boundary of the system, then that kind of the system is called as the open system here. Pumps, all these comes under this here. So next one is isolated system. Isolated system is neither mass nor that energy will crosses the boundary here. Means isolated system is somewhat, it is like this here. So this is the isolated that system here. Means the mass will not cross. Inside mass, outside not, it will not go. Outside to inside it will not go. And energy will also, maybe heat or work, energy will not cross us from outside to inside, inside to outside. Whatever it is, this mass or energy of this isolated system is there, it is constant. It does not crosses any boundaries, mass as well as energy. That kind of the systems are called as the isolated systems. So what are the example for this? If we took whole universe, in this universe, sun is there, some planets are there, everything will be there. Total universe is the boundary. Total system itself, it is the universe here now. In that earth, everything will be there here now. So in this, within this total, this boundary of this universe, imaginary, it is imaginary. Boundary is always imaginary here now. So what happens? Whatever the heat interaction, work interaction, energy interaction will take place, within the boundary only they are taking place. They will not crossing the boundary. Mass also as well as energy will not crosses the boundary. So therefore that kind of system is called as the isolated that system here. This is about the systems, the types of the thermodynamic that systems here now. Mainly what we are studying in this thermodynamics here now. So this is about the some important terms of this thermodynamics here now. Mainly we are studying here now, as I have told, heat and work here. So mainly we are studying here now, heat and work here. What is the difference between this heat and work here? Heat is what? Heat is a energy. Work is what? Work is also the form of energy. So that's why this both heat and work are there. Both are having some similarities. Maximum they have similarities, and certain differences are also there here now. If we compare this heat and work here, so what are the similarities in place of that similarities what we are getting here now? In case of the similarities, both are the form of energy here now. As I have told, work can be converted into heat, heat can be converted into that work here. That means we can these two are the interchangeable here now. So therefore this is the both are the form of energy. This is one similarity here. So next one is both are measured in terms of joules or kilojoules here now. Yes, both are the energies, they are measured in the same unit here now, and both are having a path function. Path function means, as I have told here now, PV diagram, we are getting this diagram here. This is a path through which that energy conversion is taking place from thermodynamic state 1 to thermodynamic state 2. The area covered under this, it may indicates the total amount of the heat or else total amount of the work here now. So therefore this both are the heat and work are the path functions. Both are the path functions here now. Both are the energies are there. And certain differences are also there between this heat and that work here now. How this one? The heat is there. It will be transferred by the temperature difference here now. So temperature difference must be required to transfer the heat. Means what? Always heat will transfer from the higher temperature zone to the lower temperature zone here now. How to feel it here now? If we took a red hot that one metal, kept it for 1 hour, what happens here now? Heat, after 1 hour, the temperature of the red hot that metal will be reduces. Why? The temperature reduces means the heat from that red hot metal is going to the outside. Why it is to the outside only? Because outside temperature is less, the temperature of this red hot metal is more, that's why heat will be transferred from the red hot metal to the outside here. So therefore, for the heat transfer, so always temperature difference is required here. Whereas the next one is the work transfer here. So work transfer is a physical phenomena here now. So force into displacement. So the force and how much it is displacing, that is called as the work transfer here now. So therefore, this is one that the difference what we can say here in this case here. Likewise, heat and work both are having a certain differences as well as the similarities here now. These are also called as the thermodynamic heat and thermodynamic work here now. Interaction of these two we are studying in the thermodynamics here in this case. So now I will stop here. We will continue in the next video lecture some more topics of this thermodynamics. Thank you very much.